Hello. So I come up with a quite interesting integration transformation on Twitter. So I would like to show some of the steps and the thoughts that would be useful for this type of conversion. So if you look at the left hand side on the equation, so assume let's like replace x minus 1 over x to a variable u, and then we want it seems to be like fu square du. In some way, we converted dx in terms of u, so that the left hand side will be look exactly like the right hand side. Okay, let's first take a look at the function for x minus 1 over x, for x from some small number to reasonably large number. So I choose these numbers as 0.1 because you can see that as x approaches 0, the x minus 1 over x will approach negative infinity. And if x is really large, then the dominant term will be x. So this function will look like y equal to x for large x. And what's important here is you can visually check that this function is actually monotonic. So which means you won't have any like u-shape over this domain. So let's take a look at u-substitution that probably will be kind of useful for the left-hand side of the equation. So you can assume that u equal to 1 over x minus 1 over x, and we want to solve for x because eventually we want to replace the dx part with the du. So unfortunately, anything like including like a square term of x, you probably have two branches. So one is u minus square root of 4 plus u square, and the other is u plus 4 plus u square. Okay, so we want to check which one we can use. So the rigorous proof will be slightly more tedious than the intuitive solutions. So let's take a look at the difference between these two parts. So for any u, whether it's negative or positive, you have u squared plus 4. It means the absolute value of this term will always be larger than the absolute value of u. So in this case, if u is larger than 0, but this term has absolute value is larger than u, so this term will always be negative. But if we let's take a look at this part. So for this relation, if we solve x in terms of u, so basically what to do is find inverse function for this curve. And because this curve is monotonic, this inverse function actually exists. So we can imagine that we have a line that's y equal to x, reflect this function with respect to that line. So this function probably should look like this. So which means we choose this part, okay? And for example, as you look at the y-axis, is getting from minus to the positive, like minus 3 to positive 3. So the reflection of this curve should look like this part. So we can just actually put them together. Let it pass 0, 0, and the direction is 1, 1. Okay, and let's put these two all together. So this function actually kind of looks the same, but they are just a reflection from, the with respect to y equal to x. So in this way, we should always pick this branch as the inverse function for. So the next step, convert dx in terms of the du. So what we can see that if we have u equal to x minus 1 over x, right hand side is x minus 1 over x, and with respect to x. So this means that du is actually 1 plus 1 over x squared times dx. So more or less like, and we can solve dx in terms of du by replacing the x with u's. So we want dx equal to 1 over 1 plus 1 over x squared times du, right? But eventually we want to replace the dx with du so that you have fu squared times du as the integral. So u will be sort of like dummy variable, right? And because on the right hand side of this equation we have mixed the x and u, so we want replace x with u as well. So here we can see that x equal to 1 over 2 times u plus square root of u squared plus 4. So we can just replace x with this expression and take a look at the actual expansion. So recall that it's 1 over 1 plus 1 over x squared. Okay, so x is this term. And let's take a look at the algebraic expansion for that. So eventually we can simplify this expression to 1 over 2 times 1 plus u over square root of u plus 4. Okay, here is the very interesting part of this integral. So if you take a look at the left-hand side of the integral again, you will see that you can actually split this function integral as two parts. One is the x from 0 to 1, and the other part is x from 1 to infinity. So for x equal to 0, it is sort of like minus infinity. So in the u world, you will have the integral from minus infinity to 0 for x from 0 to 1. So it's more or less like fu squared times this for u is from minus infinity to 0. So it should look like this. And from 1x from 1 to positive infinity, it's for u from 0 to infinity. So eventually you can just add them up, and the integral was actually from minus infinity to positive infinity, which is actually very close to the right hand side, right? So the only thing that we need is to cancel the part that on the right hand side of this equation with u and u over square root 4 plus u squared. And here is the trick. Because let's see, for this integral, what if I replace u equal to minus v? So if u equal to minus v, this should be v squared, and this is minus v. And v is actually from 0 to infinity. And if I add up these two parts, and recall that u and v is actually dummy variables. So in this case, I can replace u and v with everything with x. So if I add up these two and replace both u and v with x, it should look exactly like this. And in this case, you can see that the x over the square root of 4 plus x squared canceled with each other, and we can combine 1/2 altogether. So eventually, we will have exactly the same thing on the right-hand side from our original problem. Thanks for watching. See you next time.